A man leaves his home and begins walking to a nearby store at a constant speed. Halfway to the store, he realizes that he left his money at home, so he turns around, walks back at the same speed. He's at home for a brief amount of time before heading out again. Realizing that he is now behind schedule, he walks to the store at a quicker pace than he had earlier. Halfway to the store, he stops briefly to tie his shoe. So this is a purely sketching graphs problem with no math involved. And in part A, you just want to sketch a graph of position versus time for the man, starting from the moment when he first leaves his house to the moment he arrives at the store, where x is equal to 0 at his house. So, on this graph, let's just label a couple places. We have the house right at 0. We have the store, kind of be further up here, and then halfway to the store, we'll put right there. So what the graph looks like is he starts at his house, which is at x equals 0, and he just walks at a constant speed until he reaches the halfway point to the store. Then he turns around and walks back home at the same speed. So the magnitude of those two slopes should be the same, just one positive and one negative. He's at home for a brief amount of time, so we're just going to do a horizontal line at 0, and then he heads back to the store, but this time moving a little bit quicker, so the slope of the graph is going to be slightly steeper than it was before, and then halfway to the store, which is at the same height he was earlier, from here over to here is the halfway point. He stops briefly to tie his shoe, so I'm going to put a horizontal line for when he stops, and then continues walking to the store at that same speed, and stops when he gets to the store. So that's position versus time. Let's now draw a graph of velocity versus time. So this one, and we want this graph to line up with the previous graph. So he starts out with that positive velocity and then has a negative velocity, and they're the same magnitude. So it is going to be slightly above the time axis for the positive velocity, and then it dips and goes the same amount below the axis for the negative velocity. So that's the first two parts, and notice that I've got this part right here to line up with this, so that where he turns around corresponds with this line right here. Then we have the negative velocity, so the slope is downward, corresponding with this negative velocity. Then we have a period of 0 velocity, so on this graph I want to do a horizontal line at 0 that lines up with that one. So we'll go up to the time axis and put a small horizontal line. And then the next part of the graph, he's moving with a higher velocity. So we'll go and up to a higher velocity for a brief amount of time. And then he stops right here. So I want this to line up from here to here. I want that to line up on the velocity graph with a velocity of 0. So it'll go from here down to 0. And then it picks up with a positive velocity again. So that last part of the graph should line up where he has the positive velocity, because it's sloping upward, should line up with this positive velocity. And part C is to sketch a motion map that corresponds with this graph. So we have the home labeled over on the left and the store labeled on the right. So just to make things easier to see, let's label a halfway point between the home and the store. So just put a little notch on that motion map to indicate that that's where the halfway point is. And we'll start drawing the series of dots with the vector arrows to indicate the positive velocity. And it doesn't matter how many you pick, as long as you're consistent with your with all parts of the graph. So let's put the first dot at home with the arrow pointing to the right. Then a second dot after that with an arrow pointing to the right. And a third dot after that with an arrow pointing to the right. He's now at the halfway point to the store, and this is where he turns around. So we now have to put dots with the arrows going backwards. So I'm going to shift the dot upward a little bit and put arrows going in the reverse direction. So I have this 3 arrows now going to the left. Then when he reaches home, he stops briefly. So I'm going to put 1 dot with no arrow on it, indicating he's not moving. And a second dot where he's now heading back to the store, this time at a faster pace. So instead of doing 3 arrows from home to the store, or halfway point to the store, I'm now just going to do 2 arrows from home to that halfway point. And then when he gets to that halfway point, he stops moving momentarily. So I'll just put 1 dot with no arrow, and then he picks up his pace again, continuing on to the store. So I'll just put 2 arrows heading toward the store. And that's just a really rough sketch of what the motion map should look like.